So this is our task 2 now, and we are given an incomplete y versus x data set here. So we don't have the values of some y values at x equal to 4 and x is equal to 6. And we're given some quadratic splines going through consecutive data points here also. But some of the spline interpolation information is not given to us. For example, the first spline, we don't have the value of a here, so that's an unknown. Then for the third spline, going from 4 to 6, we have got 3 unknowns, b, c, and d, right? And here a, b, c, and d are constants, and we are supposed to find out the value of c. So let's start working on this. Now I have taken a screenshot for the question and put up here so we can see while we are working. And we can find the value of c by solving the third spline here, right? So the third spline here has the value c that is going from 4 to 6. But for this spline here, we have got, you can say, 3 unknowns, right? So we've got 3 unknowns here, b, c, and d, and for that we need 3 equations to set to find out the values of these unknowns. So of course, if the spline has 3 unknowns, we cannot only find the value of c without finding the values of b and d. So we need to find out all the unknowns, and for that we have to set up 3 equations. And another problem here is that this spline is going through the points 4 and 6 of x, and we are not given the value of y for these 2 points here, right? So for x equal to 4 and x equal to 6, we are not given the y values, so we need to even find out that. So to find out what is x is of 4 equal to, and what is x of 6 equal to, sorry, not x but y, right? So we have to first find out these 2 here, and what we can see is that the second spline here, the second spline is going through 4, and the third spline is going through 6. So we have 2 other splines which are going through these 2 points 4 and 6, and we could use these splines to find out what is a y value at x is equal to 4 and 6, right? So let's take the second spline, that's minus 2x squared minus 14x minus 9, and we will put in the values for this spline. So this spline is going from 2 to 4, right? That's its domain. So we'll take out the value of y for the spline going through x is equal to 4. So here we have minus 2 4 squared minus 14 times 4 minus 9. So we have f of 4 is equal to 15. Okay, so we've got one value here, and then we'll take the fourth spline now. So we have 25x squared minus 303x plus 9 to 8, going from 6 to 7. So if we put in the value of 6 here, we get 25 6 squared minus 303 6 plus 9 to 8. So we can say that f of 6 is equal to 10, right? So we've got both f of 4 and f of 6 now. Now we can use these two in the third spline, and we will get 2 equations, right? So if we use these two here, f of 4 and f of 6 in the third spline, we'll get two equations, but then we have got three unknowns still. So we need to go to one more equation. We need to find out one more equation. So currently you can say we got, if we put in the values of f of 4 is equal to 15 and f of 6 is equal to 10, if we put them in the third spline, we will get two equations, but then we still have got three unknowns. So we need one more equation to go. How do we get that? So we can get that by, if you know that splines that have a common point, the first derivative of them is same. So the slope of the second spline and the third spline are same at the common point x is equal to 4. So the second and the third spline goes through the same points, x is equal to 4 here and x is equal to 4 here, right? So we can take the derivative of both of them and equate them to get our third equation. So here we can say that d of dx, the first derivative of minus 2x squared plus 14x minus 9 is equal to the first derivative of the third spline, which is bx squared plus cx plus d, right? But these both are equal at the common point, which is x is equal to 4. So they both are equal at x is equal to 4. And now if you take the derivative, you have here minus 4x plus 14 at x is equal to 4 will be equal to, here we have 2bx plus c at x is equal to 4, right? So we have here minus 4 times 4 plus 14 is equal to 2b times 4 plus c. So we have here minus 2 is equal to 8b plus c, right? That would be our third equation. Now we know from the previous part here that if we put f equal to 4 and f equal to 6 in the third spline, we'll get our two equations. So let's write them down too. So here we'll put in, for the third spline, f is equal to 4. So we'll have b4 squared plus c times 4 plus d is equal to 15, right? So I'll just erase this part here so it just looks clean. So that is equal to 15. So if you solve that more, you'll have here 16b plus 4c plus d is equal to 15. So that's our first equation. And then putting now f of 6, so we have b6 squared plus c times 6 plus d is equal to 10. So if you solve that, you get 36b plus 6c plus d is equal to 10. And this is our second equation. And the third equation, we can just write it down from above, which is 8b plus c is equal to minus 2. So now we have got three equations and three unknowns, right? So now we got three equations for our three unknowns. And okay, I'm sure this will confuse you later on. So here, okay, now we can write them in a matrix form here. So you will have here 16, 4, 1, 36, 6, 1, and 8, 1, and 0. For the unknowns B, C, and D, it will be equal to 15, 10, minus 2, right? So I've put the linear systems into the matrices here. You know already how to do that, I hope. And then you can use any method that you know to find out the values of B, C, and D. I would just use the equations as it is. So if I write the third equation, if in where I make C the subject of the formula and I write it in terms of B, so I'll get C is equal to minus 2 minus 8B. So that's my value for C in terms of B. And now I'll take the second equation, that is 36B plus 6 times the C, and instead of the C I'll replace it with the value I just got here. So you can basically say I'm putting equation 3 in equation 2, right? So the C value, I'll replace it with the C value above. So we have 8B plus D is equal to 10. And now I'll rewrite this so that I make D the subject of the formula, and I will write it in terms of B. So let me simplify it a bit more. So here you have minus 12 minus 48B plus D is equal to 10. And then you have D is equal to 10 plus 12 minus, we have plus 48B minus 36B. So I've taken everything other than the D to the other side of the equation. And then if you solve that, you will get D is equal to 22 plus 12B, right? So I've got C in terms of B now, and I've got D in terms of B. Now I can replace this both in the first equation, that is 16B plus 4C. So instead of the C, I'll replace it with the value that we received, which is this one here. Then we have plus the value of the D, which is 22 plus 12B is equal to 15. And now if we simplify it, you'll have 16B minus 8 minus 32B plus 22 plus 12B is equal to 15. So if you simplify that more, you will have here minus 4B minus 1 is equal to 0. So you have B is equal to 1 over minus 4. So that is minus 0.25, right? So we got the value of B. Now we can put the value of B in the C here. So you have C is minus 2 minus 8 times B. So B is minus 1 over 4. So you have 4 times 1, 4 times 2, so you have C is equal to minus 2 plus 2, therefore C is equal to 0, right? So you can stop here because the question asks us to find the value of C, but anyhow I'll do the workout for D. So from here we can see that D is equal to 22 plus 12B. So you have that 22 plus 12 times B, which is 1 over 4 minus, so 4 1s are 4 3s are, and that is equal to 19. So the value of D is equal to 19. So we got all the constants here now, B, C, and D, and our answer is this one here. So the value of C is 0, right? So that's our final answer.